Good day. There's something called resonance structures in the world of chemistry. You may have encountered resonance before. Objects have what's called a resonance frequency. So if you ever taken a wine glass and it may have a bit of liquid in there and you rub your finger or moisten your finger and rub the top of the wine glass, you can get a nice ringing sound. And what you're doing is you're causing the wine glass to vibrate at its resonance frequency. Buildings can have resonance frequencies, and if earthquakes hit at that frequency, it can amplify what happens. So when something resonates, it means you've amplified the vibrations. Well, when chemicals are analyzed, they can be analyzed by what's called infrared spectroscopy. You expose the chemical to infrared radiation of different wavelengths and energies, and then you can examine where you get the greatest vibrations in the bonds, because these bonds are not static. They're sort of like an accordion moving in and out. And the infrared radiation can amplify those vibrations. And you'll say, well, what's that got to do with what we're talking about here? Well, let's talk about ozone. Ozone O3, you might expect to have two bonds, but it has three bonds. There's only two positions for the bonds, as you're going to see in a later video. And that means it looks like a double bond on one side between two oxygen atoms and a single bond between the other two oxygen atoms. But that's not the case. Infrared spectroscopy says the bonds are identical in strength. So the bonds aren't as strong as a double bond, but they're not as weak as a single bond. And so we can think of it almost like a 1.5 bond. And that's really what we do. And in a later video, we'll show how we represent that. If we didn't have this ability to analyze the chemicals with infrared spectroscopy, it would make it look like two separate bonds. We should get two different places or frequencies for vibration. But because we only get one frequency for this resonant vibration, then we know both sets of bonds are identical in strength. Confusing? Of course. The next two videos I think will be a little bit easier.